Okay, so you need to jog your memory a little bit. Inequalities. In inequality, the word is in equal, meaning not equal. They're an inequality, so it's the alligators, what you used to call in elementary school. Greater than. Less than. Greater than or equal to. Less than or equal to. Greater than, less than, greater than or equal to, less than or equal to. There's no equal sign. In our inequality problems today, there's no equal sign. Instead of an equal sign, we have these symbols. It really doesn't change anything. It just means that it's an inequality. If I say x is greater than 10, what could the answer be? 11. What else could the answer be? 12. Right? It could go on. There's infinity answers, correct? Except for anything under 10. Now that changes a little bit because if I add an equal to sign, could it be equal to 10? It could be 10 or higher, but that's only if there's that equal sign. Max, will you grab him his pencil, please? So, to solve these problems, you guys, it's the same thing. Step 1 is to draw a line down the, but it's not the equal sign anymore because there is no equal sign. It's draw a line down the inequality. Pretend it's an equal sign. It's not. That'll factor in when we graph it. But draw a line, Cody. Draw a line down the inequality. Number 2, step number 2, it's the same thing, you guys. Simplify. It's the same thing that we've done every other time. Maybe you have to distribute. How do you know you should distribute? What exists? Parentheses. Maybe you need to do both. Maybe you need to distribute and combine, like, oop, this is a tight squeeze, terms. Maybe you only do one of them. Maybe you do both. Maybe you move the smaller variable. Trade out your pencil and see if that'll help. Okay, so Cody asks a good question. If I put a star next to it, does that mean sometimes you can skip it? Yeah. So those have stars. Maybe I can skip it. Step number 4 is solve using inverse operations. And our rules have gotten a little more condensed. Because we used to say solve using inverse operations, or we used to say circle the constant, draw a square around the coefficient. We don't really need to do that anymore because you've gotten so good at doing it, right? It used to say solve using inverse operations, moving the constant first. Well, that's what we do, and then you move the coefficient. We've done it enough that we can condense our rules. But here's the big change, because all of this is the same. Here's the difference. If you multiply or divide by a negative number. If you multiply or divide by a negative number. John. If you multiply or divide by a negative number. Hint, hint. If the coefficient is negative. If you multiply or divide by a negative number. Hint, hint. If the coefficient is negative. What? Coefficient is the number. Here's the change. Flip the sign. I tried to spell sign without an I. Flip the sign. If it's a greater than sign, it flips over to a less than sign. If it's a less than sign, it flips over to a greater than sign. If you multiply or divide by a negative number, if the coefficient in the problem is negative, flip the sign. You guys, I'm telling you right now, this is the number one spot where students make a mistake. Here. This is the number one spot where students make a mistake. If you multiply or divide, you can keep it, by a negative number, flip the sign. All right, we're going to do some practice. Two x plus 4 is greater than or equal to 24. Two x plus 4 is greater than or equal to 24. Two x plus 4 is greater than or equal to 24. What's step number 1? BB? Draw a line down the inequality. We pretend it's an equal sign. Pretend it's an equal sign. It's like an equal sign, except it doesn't mean equals. It means there's a range of answers. So what's the first thing we do to solve this problem? Is there any simplifying, distributing, or combining like terms? No. Is there any smaller variable that needs to be moved? No. So now we just use inverse operations. What do we do first? Morgan? Because it's plus 4, that's our constant. That's what we get rid of first. Subtract 4 from both sides. So I'm left with 2x is greater than or equal to 20. Am I done? X is still not by itself. Inverse operations, divide by 2. X is greater than or equal to 10. And I'm done. It's basically the same thing, except instead of an equal sign, there is an inequality. And I don't have to worry about what I highlighted because I didn't divide. My coefficient was positive 2. I didn't have to worry about it. So let's try another one. 56 is less than -4 parentheses -4 plus x. 56 is less than -4 parentheses -4 plus x. Okay, so step number 1 is draw a line at the equal sign. BB, thank you. Put a 1 in there because it's 1x. That helps me multiply. John. We've done 2 examples, and you're missing out on them, please. You need to sit up all the way. And you need to start copying. Put that 1 in there so that the x isn't by itself. Does this side change? No, 56 stays the same. I do need to distribute because there are parentheses. -4 times -4 is positive 16. -4 times 1x is -4x. Do I need to combine like terms? Nope, I don't need to combine like terms. So, which number do I move first? 16. The opposite of 16 is negative or minus 16. 56 minus 16 is 40. Is less than -4x. Am I done yet? No. What's still with the x? -4. So I'm going to divide by -4, divide by -4, and I think to myself, stop, Mrs. Long. If you multiply or divide by a negative number, if the coefficient is negative, my coefficient's -4, I flip the sign. So my answer, 40 divided by 4, or 40 divided by -4, is -10, but I have to flip my sign. Instead of opening to the right, it now opens to the left. And I'm left with x. If you multiply or divide by a negative number, only multiply, only divide. If your coefficient is a negative value, you flip the sign. Now here's my other problem, you guys. I want my variable first. Correct? Yes. That's the best way to write it. So I'm going to put my variable first. I'm going to put x, and I'm going to put 10. Can I just bring this straight down? Is that the same answer? No. See how it's eating the 10? Yeah. It needs to eat the 10 down here when I flip-flop it. Here are the 2 most common mistakes students make. They make a mistake because they forget that they're dividing by a negative number, so they have to flip the sign. Or they make a mistake when they flip the problem around that they don't also flip around the problem. So let's now talk about graphing. I'm pretty lenient when it comes to graphing. Especially an inequality because it's not necessarily can you draw a line, it's do you know what the answer means. So for x is greater than or equal to 10, can you tell me one of the answers? X is greater than or equal to 10. Morgan, what's one? 11. Gabe, what's another one? 12. Grayson, what's another one? 10. Because there's that equal sign, right? It could be equal to 10 or it could be anything above it. So here's how I show that on a graph. You draw a number line, and my answer of 10 goes in the middle. Because 10's my answer. I know you learned at some point in time from somebody somewhere that a number line should always have 0 on it somewhere. Right now, that's not what we're looking for. Could the answer be equal to 10? Yes, so I'm going to put a dot at 10. Could it be 10.1?
Yes.
Could it be 10.10? Could it be 42?
Yes.
So I'm going to shade or color in everything above. Because every number from 10 and above is a possible answer. 10.1, 10.11, 10.12, 10.2, 1,000.
We just graphed that below the problem.
So this is what goes, this is the graph for that inequality. Any number 10 or greater works for this problem. Caden. What? Maybe. All right, so let's talk about this one. Negative 10 is greater than x. Or I flip it around because I want my variable first. X is less than negative 10. I want my variable first, so you have to be really careful when you're flip-flopping it. So negative 10 is my answer. Negative 10 is my answer, so it's what goes in the middle. Can the answer be negative 10? It can? No, there's not an equal sign, so I'm going to draw a fence around negative 10. Don't come inside negative 10. Don't fill it in. Draw a fence around it. Can you give me a number that is less than negative 10? Negative 11. Which way is negative 11? Up or down? To the left. So the answers are down here. Negative 62 million is a solution to this problem, right? And those numbers are to the left. Okay, so here's a little cheat sheet. You have to have your variable first. Are you listening to me, everybody?
Yeah.
You have to have your variable first. This guy right here is a no-go. You have to have your variable first, so you have to switch it around. If it eats the number, you go down. If it eats the variable, you go up. See, look, if the variable's first, I repeat, if the variable's first, look which way it points. The inequality, if that was an arrow, it's pointing this way. That's the way you graphed. If your variable's first, It's pointing this way. That's the way you graph. I repeat again, your variable must be first. It doesn't work up here where it says -10 is greater than x. That's the same thing as this one, but it didn't point the way it was going. If your variable's first, it points you in the direction of which way to shade. When do you put a closed dot and when do you draw a fence? What's the difference between a closed dot and a fence around the number, an open dot? What's the difference, Max?
The open dot is a negative.
No. Sam?
Like, so the inequality sign,
Uh-huh.
if it's, there's no equal sign below it, that's when you don't fill anything in, but when there is an equal sign below it, you fill something.
Perfect. If there's an equal sign, it's filled in. Max, you're listening?
Yes.
If it's an equal sign, it's filled in. If there's no equal sign, you draw a fence around it. So maybe you should write that down somewhere. Greater than or equal to, less than or equal to, those two ones are closed dots. Just regular greater than or equal to, or greater than or less than, no equal signs, are open dots.